Leetcode practice time. So in this video there are two goals. The first goal is to see how to solve this problem. And then we are going to put some coding here. And the second goal is to see how to solve this problem in the real interview. So let's get started. So remember, in the real interview, the first step is always try to understand the question. If there's anything unclear, please bring up the clarification question. And at the same time, think about some edge cases. So let's take a look at this question. Rotten oranges. So you're given a m by n grade where each cell can have one of the three values. So 0 representing an empty cell and 1 representing a fresh orange. Or 2 represents a rotten orange. So every minute, any fresh orange that is 4 directional adjacent to the rotten orange becomes rotten. So return the minimum number of minutes that must elapse until no cell has a fresh orange. So if this is impossible, I will just return -1. So let's take a look at this question. Example 1. So we have something like this. And finally, we are going to output 4 because this is minute 0, minute 1, minute 2, 3, and 4. In minute 4, we have all the oranges to be rotten. So let's see the constraints. M and n. Okay, so both m and n is within 110, which means the matrix is not gonna be empty. Okay, so all the values within the matrix is 0, 1, or 2. I think it's pretty clear, and I don't see any edge case at this moment. So let's get started and do some coding work. So the next step is about finding a solution before we do coding. So how to solve this problem? So this is a pretty obvious BFS problem. So I would say the first step is to go through the matrix to find all the rotten oranges and record the x and y, and we are going to put them in the queue. So remember, BFS is based on the queue. And then in the second step, we are going to do BFS and at the same time record maximum minutes. And finally, and also we need to record the number of rotten oranges. So, and the last step is we compare rotten oranges and total number of oranges. So if they are the same, then we are just going to return the total the minimum number of minutes. Otherwise, we are just going to return -1. So that's pretty much how to solve this problem. Let's see. Let's do some coding work. So for coding, we care about. So first of all, don't be too slow, and also think about the correctness and also the readability of the code. So let's see how to solve this. Put some code here. So first of all, we will have a queue, and we will have, so let's say int total oranges as equal to so this would be equal to 0, and then we are going to have the queue. So queue, this would be let's see the position. Let's define another class. Let's call it position. So in this, it has two things. The first one is the row, and this is the int row, and the column. So we are going to have the constructor for row and column. So we are going to have the queue containing the positions. Let's say this is a queue as the underlying implementation is a linked list. So first of all, we are going to let's have the row number. Row should be equal to grade.length, and the column is grade0.length. So I would say int I is equal to 0, I is smaller than row, and the plus plus I. So int j is equal to 0, j is smaller than the column, plus plus j. So we are going to put the rotten stuff into the queue. So I would say if grade I and j is equal to, so if grade ij is equal to so if it is equal to 1, so if it is equal to 1 or 2, then it is the total number of the oranges. So if it is equal to 2, it is a rotten orange. So we are going to have q.add a new position. This is I and j, and plus the total oranges. And also, if it is a 1, then we also need to do it. Grade ij is equal to total oranges. So we have the total number of oranges, and we have the queue containing all the rotten oranges at this moment. So what we are going to do next step is we are going to do BFS. So I'll say int this would be time, or let's say the minute, as equal to 0. So while queue is not empty, is empty. So we are going to get the size, the current layer, the current size layer. So we are going to have size as equal to q.size. Going to say okay, I is equal to 0, I is smaller than size, and plus plus I. So we are going to first of all pop the position, p as equal to q.pull, right? So we are going to go through the 4 different positions. If p dot row is larger than 0, we need to see. So if p dot, so maybe we can get an extension of it. Let's see if it's, we're just get a private helper function. Let's call it extend. So the extend, it would be, we'll pass several different things: the row, the column, the grade, and also the queue. So if so let's see if extend, so if row is smaller than 0, is larger than 0, then we just need to see, and if row is larger than 0 and the grade row minus 1 and the column is equal to 1, then what you need to do is we will need to set grade we will set grade row minus 1 and the column as equal to 2, and then we are going to set q dot add a new position. This is row minus 1 and column. Yes, and also if row is smaller than grade dot length minus 1 and grade row plus 1 and this is a column is equal to a 1, then we are going to say grade row plus 1 and the column is set as 2, and then we are going to we are going to add it into the queue. And similarly, we are going to extend on the horizontal side. So we are going to say if column is larger than 0 and the grade row and the column minus 1 is equal to a 1, then we say grade row column minus 1 is equal to 2. Q dot add a position. This is row and this is column minus 1, and the last step is to see the right side. If column is smaller than this is grade 0 dot length and grade row and column plus 1 is equal to 1, then we are going to say grade row column minus 1 column plus 1 is equal to a 2, then we are going to have q add row column plus 1. So that's it, and here we are just going to call the extend and pass in the row and the column number. So this is a row and this is the column, this is a grade, and this is a queue. Yep, so now we have extended so this is after we finish this layer, so we actually have plus the minutes, right? Okay, so after we do this, we finish one thing. So the thing is, actually we need to set this as -1, because consider if after we populate the first layer, like after the first layer, the first time the while loop is finished, actually we just populate all the already rotten oranges, and we plus minute, and then we have the 0. And also at the same time we need to say so this we have the total rotten oranges as equal to 0. This is a total rotten oranges plus equal to the size. And finally we will see total rotten oranges, is it equal to the total oranges? If yes, then we are going to return the minutes. otherwise we are going to return -1. So that's pretty much it about the coding. So let's do some testing here. So for testing, usually you need to go through a simple example explaining how this piece of code is going to work to the interviewer, and at the same time try to see if there's any bug within the code base. So let's go through this example. So at the very beginning, let's say we are going to have, so when the grade is equal to 1 or 2, we are going to add the total oranges. So for this one, we are going to have 7 total oranges as 7. And when it is a rotten orange, then we are going to push the position into the queue. And for the next step, we have the total rotten oranges. So we have the total rotten oranges. So one thing I can think about, what if the number of the oranges is 0? So if the number of the oranges is 0, then actually we need to return 0 actually. So I would say if the total oranges is equal to 0, then we have nothing to rot, so you just return 0 here. Otherwise we have more than 0 oranges. We need to go through this BFS. So let's see. So every time the current layer is equal to the size of the queue, and we go through every element within the queue, get the position of the rotten orange and try to extend it. So for example, when we are here, we try to extend it. We try to see the upper and bottom. So upper, there's nothing. Bottom, there is 1. So we are going to, so this is to see the bottom. So we are going to see, okay, this is a 1. We are going to add it, set this as rotten, and add it into the queue. And then then here we are going, and then we see the left and right. So this one, there's nothing on the left. So there's something on the right. We are going to have this as rotten, and then add it into the queue. So finally, I think we should return the right answer. Let's okay, so array out of bound, which is line 41. Okay, so there must be some typo here. So this should be smaller than -1. Yeah. So this one, line 41, it is still out of bound. Let's see why. So if this is smaller than grade 0 dot length -1, then we are having and the row column +1 is equal to 1. So the index -1 is out of bound of I don't understand why index is -1. So this is a row, this is a column +1. So we are going to have so it says in the extend, so in the extend function, we start from the p.row, p.column, grade, and queue. So we are trying to put, so if row is larger than 0, and we are going to put row -1 call. If row is smaller than the grade length is to be equal to 1, row -1 call. If call is larger than 0, then we are going to have row column -1. If column is smaller than number of the calls -1, then we are going to have row and column +1. I don't see, so why it is saying the index -1 how can that be possible? Yeah, that's just weird. Yeah, let me try to output something. P dot x, sorry, P dot row plus P dot column. So I think this can help us see what we are getting. So okay, so we have the 0 0 and we have the -1 0. So how can that be possible? So if it is row -1, it must have okay, so there is a typo here. Okay, gotcha. All right, so after fixing this typo, I think we should be good. Let's give it a submission. All right, so now everything looks good. So that's it for the solution of this question. If you have any question about the solution or about the puzzle, feel free to leave some comments below. If you like this video, please help subscribe to this channel. I'll see you next time. Thanks for watching.